Hello. Okay, today we are going to have a look at different sampling methods that you can use on any piece of geography fieldwork. And because I'm doing this at home in lockdown, I have decided to use these as my sample of data. There may be one or two less by the time I finish recording this. Okay, there we go. We have Aldi's finest jelly beans. Okay, there we go. We have Aldi's finest jelly beans. But we could imagine that these jelly beans are people in a population, pebbles on a beach, pebbles in a river. It doesn't matter what data set you are using, we can apply the same rules of sampling to any data set. So I'm going to create a null, a hypothesis and hypothesis to test out as we go. My hypothesis is going to be that all jelly beans are pink, and my null hypothesis is going to be that not all jelly beans are pink. So the theory always goes, or the advice is, to test against your null hypothesis, because when you're going out and collecting your fieldwork data, all I need to do is find one jelly bean that is not pink, so this blue one, to support my null hypothesis that they're not all pink. If I was going to go out testing against my hypothesis, I would need to collect all the jelly beans or all the pebbles on a beach or all the people in your sample area to prove or disprove the hypothesis. So I'd need to get all of these jelly beans to prove that they are not all pink. Okay, let's begin first of all with systematic sampling. So systematic sampling works by going on even intervals. So it could be every 10th person in a population, it could be every 10th building on a street, it could be every 10th pebble that you pick up, it could be every 10 meters distance. So it doesn't really matter what scale you are using, that would be systematic. You're doing it every 10 meters or every whatever. So using my jelly beans, I'm going to pick every 5th jelly bean to pick out of my population to be the jelly beans that I will sample. I might interview them, I might survey them, I might give them a questionnaire, but they're going to be my sample set of data. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So they are the 3 jelly beans that I would use as my sample set. Okay, you might have already spotted the first problem with systematic sampling is that it's purely by chance that the 3 jelly beans selected from my systematic sample happen to be blue. And that's given me a misrepresentation of that entire population, because not all those jelly beans in that population are blue jelly beans, but the ones that I'm sampling happen to be. I have overlooked the 4 jelly beans in between. If I had done a smaller scale, perhaps every 3 jelly beans, I would have got a better selection where I can see a better representation of the population. I can see a better selection of colours. So you need to think really carefully when you're selecting your systematic sample size that you get a broad enough range of data that you can cover a wide area, but you don't want it too big that you might overlook some little details in between and end up with a sample set of all blue jelly beans. Okay, so for that null hypothesis, which was not all jelly beans are pink, I can accept my null hypothesis that not all jelly beans are pink because what I selected out was blue jelly beans, and I reject my hypothesis that all jelly beans are pink. Let's try now stratified sampling. So stratified sampling is when you pick out a strata or a subgroup within the data you're collecting. So for population, your strata could be age, gender, ethnicity, religion. There's loads of things that you could use. For looking at my population of jelly beans again, I want to make sure that I get a representative from every jelly bean colour. so that they are all equally represented. So I will need a yellow one, an orange, a red, a blue, a little light green one, pink, and a dark green. There we go. So that is now my sample group, and they're the ones I will use to interview or survey or assess. So what I have ensured there is that I've got one representative from each of the subgroups, and from that I can now see that my null hypothesis will be accepted because not all jelly beans are pink. So you would need to go into your research knowing full well what your subgroup categories are. We don't have the issue of picking out just all blue jelly beans like we did with the systematic sampling, but there is quite a big degree of researcher bias behind this, in that I've decided what the subgroup's going to be. So I decided that I would choose this based on jelly bean colour, but whatever you decide, that's got bias behind it. So you might choose age as a factor to investigate in population. So you're putting bias behind that by selecting out age as being a key factor, when the key factor could be something else. Okay, the final method is random. Now this could be used, I find it easiest online using a random number generator. If you're using this to try and identify a location, so a place or a site where you're going to collect data, you can use grid references from an OS map, or you could use longitude and latitude, or you could overlay any map with your own grid that you've designed and put numbers on. You could use postcodes as well, and what you'll do is input your number ranges onto a random number generator, and that will pick out your locations. Okay, so let's try that. So I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 jelly beans. So on the random number generator, I will need it to select numbers from 0 to 15. Okay, so the first number picked out was 15, which is the end one. Then it was 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the third one, 1, 2, 3. Okay, so what's great about this method is you have got absolutely no bias as a researcher. You've got no control over what's being selected. But again, a little bit like systematic, purely by chance, I've got 1 blue jelly bean and 2 reds, and nothing from the other colours being represented. So this is the best in terms of removing any researcher bias, but just be aware that you haven't got that control, and your population that is selected might not be representative of the whole population that you're researching. So I hope that helped, and I hope it made sense. Make sure that whatever you do, you start off with a hypothesis and a null hypothesis, that you really consider what sampling strategy is going to be best for you, whether you need to have one representation from each subgroup in a population or in a beach, whether you want to be completely random about locations or what's chosen, and then you can test your hypothesis using your sampling techniques. So I hope it's helped. I'm off now to enjoy my jelly beans, and I will see you next time.